Going to be discussing compound inequalities. So let's start by discussing what is a compound inequality. So a compound inequality is just an inequality that is made up of two linear inequalities just kind of smushed together. What are the types of compound inequalities? Well, there are two types of compound inequalities. There are the and inequalities, and there's also the or inequalities. All right, so here's an example of an and inequality. X is greater than 2 and x is less than 9. Here I've got x is less than -1 or x is less than 5. So we're going to go a little bit more in depth into what each of these inequalities means. So we're going to start with and inequalities. So and inequalities are inequalities where both parts of the inequality can be true at the same time. They can be written in two ways. So here's one way. X is less than or greater than -5 and x is less than 3. And so the way I can think about this is I can be like, is it possible for me to come up with a number that is both bigger than -5 and smaller than 3? And I can, for example, 1. 1 is bigger than -5, that's true, and 1 is smaller than 3. The other way I can write an and inequality is like this, as just one inequality. Here I can see x is bigger than 5, right? X is bigger than 5, -5, and x is smaller than 3. That's just these two inequalities smushed together. Once again, I can think of a number. I'll try a different number that falls into both of these. A number that's bigger than -5 but smaller than 3. How about like -2? -2 falls in this range, that it is both bigger than -5 and smaller than 3. And when I go to graph this, we're always going to shade between my two endpoints. So here is the graph of x is greater than -5 and x is smaller than 3. I don't have any equal to bars, so my two dots are going to be open. My two circles are open. And when I shade, I'm thinking, okay, x is greater than -5, so here's -5. Here's 3. X has to be numbers that are bigger than -5, so -4, -3, -2, 0, and so on. X is smaller than -3, so or x is smaller than +3, so here's 3. I want numbers that are smaller than 3, like 2, 1, 0, so on. So we're just shading that space in between them. So those are and inequalities. Moving on to or inequalities. An or inequality is an inequality where only one of our two parts can be true at a time. There's only really one way to write that, with the word or in the middle. So here is like x is less than 10, or x is less than -10, or x is greater than 6. It's impossible for me to think of a number that falls into both of these things. For example, if I want a number that is smaller than -10, I could say like -12. If I want a number that is bigger than 6, I could say 8. But if I tried to say -12 is bigger than 6, that's not true. And if I tried to say that 8 is smaller than -10, that's not true either. So only one of these can be true at a time. That's why it's an or inequality. When I shade an or inequality, I'm always shading to the outside of our two endpoints. So here I've got my circle at -10 and my circle at +6. I already said one of my numbers that can work for x is less than -10 is -12. And I said that one of my numbers that can work for x is greater than 6 is 8. Notice when I plot those 2 points, they are on the outside of my circles. And that's always going to be true for an or inequality. Because it can't be true for both at the same time, one's going to go in one direction, one's going to go the other direction, and you're just going to shade to the outside. So let's talk about how to solve and graph a compound inequality. So to solve and graph a compound inequality, there are 3 steps. Step 1 is to separate your inequality into your two inequalities that you're going to solve. Step 2 is to solve each one of those inequalities separately. And then step 3 is to graph those inequalities on the same number line. So we're going to look at some examples and follow these steps. So if I'm going to do, for example 1 here, it says to solve and graph, and I've got 17 is greater than 3x plus 2 is greater than negative 22. So this is a and inequality, because only and inequalities can be written as this one inequality together. So my first step is going to be to separate it out into two separate inequalities. So I'm going to write 17 is greater than 3x plus 2, and I'm going to write 3x plus 2 is greater than or equal to negative 22. I just took this part of the inequality and made it its own thing, and I took this part of the inequality and made its own thing. So I'm going to solve each one of those inequalities using our steps for solving. Subtract 2. I'm actually going to solve these simultaneously. I'm going to do them at the same time because it's the same work. Subtracting 2 all around gets me 15 is greater than 3x. And over here it gets me 3x is greater than or equal to negative 24. Then I got to get rid of this 3, so I'm going to divide by 3 everywhere. Over here that gets me 5 is greater than x. And over here it gets me x is greater than or equal to negative 8. So I'm going to go ahead and graph these things. 5 is greater than x. First thing I want to do, I want to think of one number. I always like to do it this way, where I think of one number that could go in for x. So 5 is greater than, say, 2. Okay? So I know that 2 is going to be in my solution area. So I'm going to go over here. I'm going to put an open circle at 5, because there's no equal to bar. I'm going to go ahead and put a little dot here, because I know I'm going to be shading where that 2 is. I'm going to do the same thing for x is greater than or equal to negative 8. Circle at negative 8. Because of the equal to bar, it gets closed in. Then I'm trying to think of a number. Maybe it's this same number. We know for an and inequality, it should be true for both at the same time. So let me think about that. Is 2 greater than or equal to negative 8? It is, so 2 works for both of them. And like I said, for and inequalities, we always shade between our two endpoints. So I'm just going to shade that area in between them, which means that any point that falls in this shaded region is a solution to both of my inequalities and my compound inequality as a whole. Okay, so next up, example 2, solve and graph. So this is an OR inequality. It says it right here. And for an OR inequality, I know when I graph, I'm going to be shading outside. Now, OR inequalities are already separated into two separate inequalities for me. That's pretty sweet. So I'm going to go ahead and solve these each separately. So I've got negative 2x plus 8 is greater than 0, and negative 12 is greater than or equal to negative 2x plus 8. Notice my variable side is the same on both of them. So I'm going to start by subtracting 8. I'm going to solve both of these inequalities at the same time. So I'm going to subtract 8 all around. I get negative 2x is greater than negative 8, and negative 20 is greater than or equal to negative 2x. Then to get rid of that negative 2, I'm going to divide by negative 2 all around. I get x, and I'm remembering that when I divide by a negative, I flip my inequality symbols. So I get x is less than 4. And over here, I get 10 is less than or equal to x. Let's go ahead and throw the word or back in there. So here are my two inequalities. X is less than 4, and 10 is less than or equal to x. Okay, so looking at this, when I go to graph it, I'm going to say, okay, x is less than 4. What's a number that falls into that? Well, 2 is less than 4. So if I put my circle at 4, no need to fill it in because there's no equal to bar. And I'm going to put a dot at 2, so I know that I'm going to be shading this one this way to the left. And then 10 is less than or equal to x. I'm trying to think, what's a number that 10 is smaller than? Well, 10 is smaller than 12. So if I put my circle at 10, this one gets filled in because there is an equal to bar, and a dot at 12. That tells me that I'm going to shade my second inequality over here. That one's going to get shaded to the right. And notice if I shade this one to the left and this one to the right, I'm shading outside. Just like I said, we will always shade these outside of our two endpoints. So that's all there is to solving and graphing compound inequalities. So I'm going to leave you with this try it problem. You need to solve and graph 33 is greater than or equal to 4x minus 3 is greater than or equal to 9.